Okay. Now, you gotta be careful here. First of all, you want to know what f of x minus h is, right? That's the first hurdle. You gotta get f of x minus h correct. To get f of x minus h correct, and let's make sure we got all this on the screen. Well, let me get it over here. We'll stay out of the way. Okay. We start with the formula for f of x. I said that f of x is the toolkit reciprocal function. So you really need to write out f of x equals 1 over x. Everybody knows that's a reciprocal function. But some people out of habit from what we did last time put a square on that. That's fairly harmless. It's easier to solve if it's the reciprocal function rather than the reciprocal square. Okay. But again, I think everybody knows what those functions are, which is great. At this stage of the course, I hope so, and I'm glad to see it. Okay. Then what's f of x minus h? You don't write down anything except what follows from this and this expression. If you do, you're probably going to write something down wrong. Okay. Now, if you can see it in your head, that's okay. What? X has been replaced by x minus h. Everybody got that? Because it's still a point of confusion in a significant number of people in this class. Okay. Now, a lot of people aren't confused either, but yeah, it's probably 60-40. Okay. X has been replaced by x minus h. Therefore, we replace this x by x minus h, right? So that's 1 over x minus h. Now, I don't want you to put numbers in at this stage. You probably can, but I want you to be sure you can do the form of this thing, because there are two ways I can ask this question. One is just with the symbols. Okay. And you have to know how to do the symbolic solution. And you might review that from what we did last time. It's going to be easier to understand what I did with the symbols last time if you can do it with numbers. Okay. But we want to be able to do it with symbols. So the first thing we're going to do is going to write this out with the symbols. Then we're going to plug in the numbers. Okay. So if f of x minus h is this, a f of x minus h plus k, well, what I've written here is the equation. Here's the equation. Now, what is that equation? Well, it's not what I wrote down last time because we're doing the square root function. So we'll kind of unfold this one layer at a time. We figured out what f of x minus h is. So this is a times 1 over x minus h plus k equals d. And now here's our equation in symbols. So this equation becomes this when f of x is the reciprocal function. Now we can plug in the numbers. A is -3. H is 5, so we get 1 over x minus 5. K is 12. And D is 6. And now we're going to solve the equation. You see the board, okay? So let's write the equation again. We get -3 times 1 over x minus 5 equals plus 12 equals 6. What's the first thing we're going to do with this equation? Well, the first thing we do is we're going to plug off that 12 there. We don't want the 12 there. We don't want the 3 there. We don't want the 5 there, okay? we'd easily get rid of that 12. Actually, yeah, that's not the way I did it before, but I'm actually gonna do it that way. No, yeah, no, I'm debating. Okay, I'm gonna get rid of the 12. I'm gonna say -3 times 1 over x minus 5 plus 12 minus 12 equals 6 minus 12. I prefer you write it out this way because it reinforces the fact that you're subtracting 12 from both sides, which confirms that it's a valid step. If you write down a bunch of magical symbols because out of habit, not saying that this is what we're doing, you might get confused when you try to do it with symbols, okay? You want to reinforce the idea that you can add or subtract the same quantity on both sides, and that's what you're doing. Okay. Now I'm going to write this as -3 over x minus 5. It's like -3 over 1 times x minus 5. Numerator times numerator, denominator times denominator gives you this. And that's what you have to know about multiplying fractions. It's not a magical thing. It's just you multiply numerators and you multiply denominators. I think you know that, but you want to reinforce it because when it gets symbolic, it can get confusing. Okay. So here we have. Okay, now what do we do? Well, we do what we maybe would have been well off to do at the beginning, but it's a little simpler here. We multiply both sides by the denominator. Now, I usually say multiply both sides by common denominator if there's any denominator at all, because you don't want to deal with fractional expressions. You get rid of them. Okay, so you multiply by x minus 5. Okay, well, to multiply this, it helps to put a 1 there, just to emphasize, you multiply numerator by numerator, denominator by denominator, okay? And you could do that, but notice you're going to get the same denominator if you use the x minus 5 here and the 1 here. And then you have x minus 5 over x minus 5. I love this so much, it chokes me up. You got x minus 5 over x minus 5 times -3 over 1. And that gives you -3. You can cross things out if you want, but it's dangerous because people don't know the rules. Some of you do. If you're sure you know the rules, go ahead and take your chances. Okay. Now, we use a distributive law on the right side. We get -3 equals -6x plus 30. So that -3 minus 30 equals -6x plus 30 minus 30, giving us -6x equals -33. Then -6x divided by -6 equals -33 divided by -6. So that x equals -33 over -6, because -6 over -6 times x over 1 is 1 times x over 1, that's x. And this reduces down to 11 thirds, 11 halves. Okay. And that's 5.5, and that's what I saw several people getting, okay? So if you got 5.5, you're good. If you did anything wrong at all, you're not going to get 5.5. Okay, and make sure that the big pitfall is getting your f of x minus h. Write it out like this. Don't skip that step. If you write it out like this and understand that x has been replaced by x minus h, then you're going to replace x by x minus h, and you're going to get off to a correct start. Doesn't mean there aren't pitfalls after that, but that's the biggest. Then again, I recommend that you write this out in symbols, because you're going to need to be able to write it out in symbols. Maybe I don't give you the values of A, H, K, and D. Okay? Then you got to solve this. Now, I did that last time with symbols. I think I did it for most of the forms. If not, ask me and I'll do it. next week as we get into more review, okay? Since I gave you numbers there, we have it. Now, one other thing I could do with this. I mean, I give you any toolkit function, there are at least 7 of them. Okay, the 3 that we started with, squaring, exponential, reciprocal, then you got reciprocal, square, and cubing, okay? And then we got inverse functions, which is the square root and the log. And we also have the absolute value function. I think that makes 8. I probably won't ask you anything about any of the others without a little more explanation, without telling you what the function is. Because those are the big ones. 99% of the functions you're going to see, even if you go through calculus, are those that, and I should qualify that, there are the trigonometric functions. But in a lot of curricula, you don't need to do trigonometric functions. There are only a few of those, okay? If you understand this scheme, it'll make it easier to understand trigonometric functions if you need to take the second semester of this course, okay? If you're going directly into an applied calculus or something else, then you won't need to worry much about the trig functions. Okay. Another way I could phrase this is I could say, solve this equation where the vertical stretch is this, the horizontal shift is this, and the vertical shift is that. Okay. I could even throw in a horizontal compression, but I won't do too much of that because we haven't actually talked about that too much. Okay. And it really isn't relevant until you get to the exponential function. I'm satisfied if you know this scheme. It's a little bit of a surrender on my part to the fact that COVID has impacted math education. Okay. It's an important idea, but I think you can understand it when you get to it, and you've also done it at home. So we're not going to emphasize detailed understanding of that. All right. So there it is. Now there are a few more that I'm going to go over really quickly. I also appended to the videos from last time, a 10-minute video where I do 4 of these. Okay. Now I just wrote them out and then pointed. And that's all I'm going to do here. I'm going to take what I wrote out last time. We've got other things to do today. There you go. Get the idea of matrices and stuff like that. But here we go. Okay, same thing, AF of X minus H plus K. Just a there's the form that we're going to use. We're going to use the same numbers we used before. A is still -3, H is still 5, K is 12, D is 6. For the scoring function, here it is. Okay. And the process is very similar. Subtract 12 from both sides. The 12 goes away. Divide both sides by -3. -3 goes away, leaving you X minus 5 squared. And you do the arithmetic on the right-hand side, you get 2. Okay. Now, just for comparison, what do you do if you have an exponential equation? You subtract 12 from both sides. Then you divide both sides by -3, and you get an equation that you can change to a logarithmic equation. It starts out exactly the same as the other. Okay, now I do something a little different with the reciprocal square function. In any case, what do you do when you get down to X minus 5 squared equals 2? Well, your reflex is probably take the square root of both sides. But you have to understand that the negative square root of this side will also give you a solution, right? Because if I've got a number in my head, its square is 738.382756. Okay, you immediately figured out what that number is, right? Well, you can immediately get the square root of that number. If you haven't, you can get in your calculator, right? You can at least approximate it. But the negative of that square root also solves the equation because we're talking about this thing squared equals this. Okay, so whatever you square to get 2, if you square the negative of that number, gonna have a negative times negative, still gonna give you 2. You have to understand that to be secure in solving equations like this. It's not just a rule that square root is a plus or minus. People get that screwed up all the time. Okay, the reason you get a plus or minus is because when you square the square root, you get the number. If you square the negative of the square root, you get the same thing. Okay, so take some note of that or whatever. Try to understand that because it makes things simpler in your future as well as in your immediate future because you got a file coming up 2 weeks in a day. That's a deadline. Okay, it'll be available a week and 3 days. Okay, no, week and 4 days. Week and 3 days will be something will be available. Okay. Okay. Now my point is that solution to x minus 5 squared equals 2. There are 2 solutions. One is where x minus 5 is the square root of 2. Because if you square the square root of 2, you're going to get 2, right? So if x minus 5 is the square root of 2, then x minus 5 squared has to be 2. Or x minus 5 equals negative 2. Because if you square, if x minus 5 is negative 2, this says square negative 2. Well, negative 2 times negative square root of 2 times negative square root of 2 is positive, and it's 2. Okay. So it's this, and I should put the logical word in here, or. There's an or here. Solve this, x minus 5 equals the square root of 2. You're going to add 5 to both sides, and you're going to get x equals square root of 2 plus 5, which would usually write as 5 plus the square root of 2. We usually write the whole number up front. Okay. And if you do this, you add 5 to both sides, and you get 5 minus the square root of 2. That's the solution. Understand all those steps, understand why you take those steps. Because this is something you're going to see. Okay. Go to the exponential function. Again, we do the same few steps at the beginning. We know if we subtract 12, it's going to go away, and we're going to get negative 6. I didn't write out every step here. You want to write out every step when you do it to reinforce what you're doing and show me you know what you're doing. So if you make a mistake, I see what the mistake was rather than having to give you the maximum possible penalty for having made that mistake. Okay. Now, if everything else is right, you're still going to get the substantial credit of the problem. But you know, if you make a mistake without documentation, it costs you more than if you make it with documentation. Show me what you're thinking, show me your steps. You'll learn more that way anyhow, if you're in the habit of working with that. Okay, if you're in a hurry, sometimes you skip steps, but it's really not a good idea. Okay, anyhow, we get this equation. Well, we divide both sides by negative 3. And we're going to be left with 2 to the x minus 5 here. And negative 6 divided by negative 3 is 2, just like it was over here. Okay. And then what do? Well, we change this to exponential form because the variable we're after, which is x, is in the exponent. I said change it to exponential form. It's in exponential form. We change it to logarithmic form. Just to review, right here is the equivalence. The way I've written it out in several ways. B to the a equals c is the same as a equals log base b of c. Okay, or log base b of c equals a. That's because of the inverse function relationship. It goes back to first thing we did to get the inverse of the exponential function, toolkit exponential function, we switch columns, which switches the X and the Y in the graph and gives us the shape of that graph. You need to know how to do that. And I will ask you how to do some inverse function. Okay. You're switching the X and the Y values. And what that does then is it gives you the logarithmic function. And you identify A, B, and C. In this form, you identify A, B, and C. A is the exponent, that's X minus 5. There it is. A is X minus 5. B is the base of the exponential, and that is clearly 2. And C is the thing on the other side, which is also coincidentally 2. I didn't plan it that way, it just came out that -6 divided by -3 is 2. Okay, so this could easily be a number just other than 2. 2 is real convenient because log base 2 of 2 is 1. And you don't need a calculator to do that if you understand the construction of the inverse function or the inverse function relationship. If you do need a calculator, you can do it. You'd have to do log 2 over log 2. Okay, in any case, when this is rearranged to logarithmic form, we get X minus 5 as log 2 of whatever number we have here. In this case, the number is 2, so we get X minus 5 equals 1. And we add 5 to both sides. Don't skip the step, do it. X equals 6. Okay. Another thing you want to do on the exam is you want to check everything. So you put in 6 up here. What's 6 minus 5? It's 1. What's 2 to the 1? It's 2. What's -3 times 2? It's -6. Add that to 12. -6 plus 12 is 6. So you actually check this one in your head. And I do want to see a check. If you get the wrong answer and haven't checked, it's going to be more of a penalty than if you did check. Okay? Maybe not a whole lot more, but if you do it in every problem, it'll mount up. Okay? It's going to cost you at least a point. And depending on how bad the mistake you made in the problem was, might cost you a couple, in addition to the penalty for having made the mistake in the first place. Okay? I want to see checks. If you don't have time to check, you just say, man, I'm pretty sure of this. I don't have time to check. I've been working on this test for 12 straight hours. I got to eat or I'm going to die. Something like that. Get in that situation, I'd rather you lose a few points in the test than die. Okay? I don't even want you to really suffer that much. All right. Now, with this equation, things get a little more complicated. Okay? I've got a denominator. Now, I chose, instead of subtracting the 12 from both sides, makes it a little more complicated, but my reflex, if I don't have a very good reason to do something different, and if you're not really confident on it, I'd better multiply both sides by that denominator. Okay? Because it clears denominators and you don't have to worry about fractional expressions till you get to the end. Meaning you're much less likely to make a mistake. Okay? If you try to do all the fractions and screw it up, I'm going to penalize you for not multiplying by that denominator, if that's the reason you screwed it up. Okay. Again, if all your steps are correct and depending on how important it is to have done it right, might be a bigger penalty or lesser penalty. It depends on the situation. Okay, so anyhow, we multiply both sides by X minus 5 squared. So this side becomes X minus 5 squared multiplied by the whole side, distributive law. Don't multiply it by just this thing. Okay, you got to multiply it by the whole side or the equation becomes unbalanced. And then you got to multiply it by the other side or the equation becomes unbalanced. Okay, you multiply one term by a number, you're going to multiply every term on both sides by that number. I write x minus 5 squared over 1 because I'm going to be multiplying it by a fraction here. And I want to reinforce that I multiply numerator times numerator and denominator times denominator. Okay. So it's going to be this times this, which is here. And then this times 12. And I didn't bother writing the over 1 here when I multiplied by 12 because I don't have a denominator in the 12. Okay. I don't even have to write the 1 here, but I need to understand it. And it's more secure if you actually write the 1. Until you've done about 100 of these, and then you know what you're doing. Okay. So that's what I get over here. On the right-hand side, well, I chose to do this. I can't I can't distribute the x through this square until I first do the square. What's the square of x minus 5? There's a strong tendency for people to want to say it's x squared plus negative 5 squared. That's a strong penalty. Okay. Do that and you lose half credit on the problem automatically, even if you do everything else right. Okay. I'm not just to avoid the penalty, it's to avoid making that mistake in the further distant future where it could be even more damaging. Okay. Somebody puts you in charge of putting the spacecraft on Mars and you do that and it's going to crash. Going to lose $30 billion and they're going to take it out of your paycheck. Well, you're not going to be in that position. Okay. Very much here. I'm not going to. The only people that put in that position are people who just don't make mistakes. And sometimes they do. They did in the 90s and lost a multi-billion-dollar spacecraft. One stupid error. They'd have been in my physics class and would have never made that error. Okay. Down here. Multiply this by this, right there it is. Multiply this by 12, right there it is. Multiply this here by 6, there it is. We square the x minus 5 using the distributive law. X minus 5 times x minus 5, okay? And we get x squared minus 10x plus 25. So that's just more common error that I really hope I don't see, because I hate to penalize you for something that you really could have avoided. Okay. Well, multiplying this by this just gives us -3. Because the numerator is going to match the denominator. Well, this part of the numerator is going to match the denominator. We could write this as x minus 5 squared over x minus 5 squared times -3 over 1. Doesn't matter if the x minus 5 is here or here. When we multiply the two, our denominator is going to be x minus 5 squared. So put the x minus 5 squared here and the 1 here. X minus 5 squared over x minus 5 squared is 1. If you remember the rules for cancellation, which almost nobody ever does consistently, correctly, okay, but don't make mistakes with cancellation. Okay. Bottom line is, this term comes out -3. This term is still 12. Well, it's 12 times x minus 5 quantity squared. We square the x minus 5 again, and we get this. Okay. Now, in this step, I've multiplied the 6 through squared x minus 5. In the next step, I'll multiply 12 through this polynomial here, and I'll get this equation. Now, how many of you know what kind of an equation that is? This is a quadratic equation. Okay, it's got x squared, it's got x's, it's got numbers. None of the x's are in the denominator or anything. Where do the exponent like that? Okay, so it's not exponential. It's just a plain old polynomial equation of degree 2. Highest power is 2. Okay, so what do you do when you have a quadratic equation? You identify it as quadratic, And then you put it in the form ax squared plus bx plus c equals 0. And you apply the quadratic formula. Okay. So I just say, etc. At this point, well, how do you get it into this form? Well, you subtract off 6x squared, you add 60x, you subtract 150 both sides. You just subtract this whole thing from both sides and simplify it. And if I did it right, you get this. And if I got my numbers right, you get this. I got a question mark on this number, 3408. Almost looks like a 68, but it's an 08. Kind of think it might be right, but I think maybe it should be a little closer to 3600. Okay. And you just use your calculator. Okay. And this is one of the few places where decimals are required. You can't do this with fractions because that's not a fraction. Okay. It's an irrational number. Goes on, never any pattern, never ends. Actually, irrational numbers can have patterns with square roots still. Okay. Now that's a whole lot about equations. Do all that, it's pretty good. If you have an absolute f of x is the absolute value function, which it could be, remember it's going to split into two equations. If you have the absolute value of x minus 5 squared equals 2, which is what you would end up with if f of x was the absolute value function. You'd split it into x minus 5 equals 2, x minus 5 equals -2. Because the absolute value of 2 is 2, and the absolute value of -2 is 2. Would it be a square root in that case? I'm going to write it out like this. Okay. That's a big deal. I'm going to have to do that. Now there's more, and there's more stuff I want to review. I want to give you a brief introduction to matrix multiplication with some motivation. And I'm going to use boards that I created last time, but first I'm going to start it off by writing a lot of it. Okay, so we have this exam time, right? Let's say we've got 1,000 students coming into exams. They've all got at least 3 exams. Okay. It's the end of the semester. I'm going to say 500 of those 1,000 students are basically sane. And 500 are mildly demented. Okay. Demented means literally kind of losing your mind a little bit. Anybody want to admit to kind of losing your mind a little bit at finals times? Well, don't put yourself in the spot. I know I did. Okay. Now, under the pressure of exams, that pressure is going to drive some of these sane people to dementia. Okay. So if they're sane today, you know, week and 4 days from today when finals start, maybe they get to the mildly demented. They're not going to be criminally demented. They're not going to be so demented they have to be locked away. Most of them. Okay. They're just going to be, you know, walking into walls and, you know, minor stuff like that. Okay. Going to a wrong room for exams, forget what they should know. Okay. Stuff like that. Okay. So, and I'm going to use capital S for sane and capital D for demented. Okay. Now, here's what happens. Each exam, 10% percent of your same become demented. However, the pressure of the exams is such that even more demented people become sane, even a greater percentage. You know, it's like you're a little demented, you pull it together and you ace the final, which I hope everybody does in this case. Okay? Case of all your courses. Okay, please do well. So I'm using DNS. You just noticed something. I'm using DNS to denote demented and sane. Those happen to be my initials. Nice ever noticed that. I've been using this thing for decades. I invented it to explain matrices. Yeah, other less entertaining ways to do it. Okay. Well, now I've drawn a picture. Well, let me just draw a picture. Okay, I've got 500 sane. So this is the number sane. This is the number demented. Some of the sane become demented. Some of the demented become sane. How many sane people are going to become demented? Can you show me with your fingers? You're probably going to need two hands. Most people got fingers up, have kind of the right number of fingers. 10%. What's 10% of 500? It's 50. Okay. Don't know that. Probably too late to learn it now, but try to learn it in the future. 10% means 1/10. Okay. Okay. How many of the demented are going to become sane? Well, 20% is twice 10%, right? What's 10% of 500? Well, it's 50. So what's twice that? 55? Oh, wait, no, I screwed it up. It's 100. Okay. Yeah, it's 100. You can screw up anything in finals. But fortunately, pressure finals tends to make the dementedness that causes you to do these screwed up things be among the 20% that become sane and don't make those mistakes. Okay, so here we have. So how many sane are we going to end up with after the exam? Give you a hint. 50 of them are going to become demented, but 100 of the demented are going to become sane. So what's that going to do? Yeah, it's going to increase the number of sane because you got more demented becoming sane and sane becoming demented. Now, again, due to overuse of calculators, people don't immediately see this. They don't immediately see numbers because they're used to punching it into a calculator. They don't visualize it. And some people have trouble visualizing numbers too, but not that many. Way too many people can't just see this clearly. Okay. But you're going to get 550 here and 450 here. Okay. 500 minus 50 plus 100. If you write it out, 500 minus 50 plus 100, shouldn't have to write that out, but if you do, you need to punch it into a calculator. At this stage, I can't tell you to do differently. Okay. Now, what's going to happen? Well, we're assuming everybody's got at least 3 exams. So what's going to happen in the second exam? How many of the sane are going to become demented? What? Going to be 10% of the same. What's 10% of 550? You shouldn't need a calculator to do 10%. Okay, just move decimal over one place. But anyhow, it's 55. And what's 20% of 450? A little less than that. 20% of 100, 500 would be that. Okay. 20% of 450. Well, what's 10% of 450? 45, right? What's twice that? What's 45 and 45? It's 90, right? So we'll say 900. 90. And if you add these numbers up, you find that you have then 585 here and 415 here. Okay. Now I'm going to put a little transition one takes us from here to here. The word transitions necessarily just a little bit too small to read, but that long word there is transition. Transition one, transition two. Okay. You got a third exam, you get to do it again. Okay. Now, when I do it, I keep getting decimals where I shouldn't. I don't know what's wrong with me. But I've got it locked in my head and it ain't going to go away. I don't know. Actually, it's okay. Okay. I was expecting to get whole numbers for both of these, and I wanted whole numbers, but there's no reason I should have done that. Locked in my head because it was right. I just didn't recognize it as right. 10% of 585 is 58.5. 10% of 415 is 83. So you're going to have a net change of 35.5. No, it can't be 35. 25.5. 24.5. Okay. And that's going to give you them. I don't like that. Somehow that number isn't sitting well with me. Anyhow, you can figure it out. Okay, well, that's good. Now there's an easier way to do it, quicker way to do it. And here it is. Now this is the same thing you just saw. Don't worry about where I got the numbers just yet. We got 0.9 and 0.2 and oh, actually, hold on. There is something I did here. Yeah, I should be showing you. Okay. Okay. So this is the same thing you just saw. Okay. From here to here, but this is new. And I gave you a little more explanation wherever it is now, right there. Okay. I'm going to write 0.9 and 0.2 here. Okay. This is a row. It's got brackets around it. Now, if this is a row, what are you going to call this? I'm going to call it a column. And of course, I wrote it there, but not everybody can read that from what they're saying. Okay. This is a column, a row and a column. I'm going to multiply the row by the column. Here's how we multiply a row by a column. Take the first number in the row, multiply it by the first number in the column. Take the second number in the row and multiply it by the second number in the column. Okay? And then if there's a third number in the row, there better be a third number in the column or you can't multiply it. Okay? And a fourth number in the row times a fourth number in the column, all the way down to the 3 millionth number in the row times the 3 millionth number in the column. And calculations are actually done with matrices much bigger than that. And they kind of govern half of what goes on in finance. But anyhow, right now we have a row of length 2, a column of length 2. As long as the length of the row and the length of the column match, we can match up the numbers in the row with the numbers in the column. Everybody got that? That seems pretty reasonable. Well, if I do that, then I'm going to multiply 0.9 times 500. Well, there it is. and 0.2 times 500, there it is. And I'm going to add them. Okay, not sure I said we add them, but we match them up and then we add the products. So it's this times this here, plus this times this here. And we add them up, we get 550. Okay. There's an easy way to understand why we get 550. They didn't explain this in the MDE course, okay? Well, first of all, the 550 matches this number, right? And then if we use these two numbers, we get our 450. Okay, same pattern. What's 0.9 as a percent? 90%, right? What's 0.2 as a percent? 20%. If you don't know that about percents, make yourself a note. First time you get bored over Christmas vacation, go to YouTube or whatever and review percents because you really need to understand. And it's another thing that I find people often are shaky on. Okay. Okay, well, what's 90% have to do with our model? Well, if 10% of the same become demented, how many percent of those sane people remain sane? 90%, right? If 10% become demented, then 90% are still sane. That's where the 0.9 comes from. Okay. So if we multiply 0.9 by 500, this 500 represents the number of sane people. Okay. So we're taking 90% of our sane. And 0.2 represents 20%. Well, that's 20% of our demented. So right here is 90% of the sane. That's the 450 that remain sane. And 20% of the 500 is the 100 sane that become demented. So we're going to end up with the sum, which is 550 sane. Similarly, this is going to give us our number of demented because this is 10% of our sane added to 80% of our demented. 10% of our sane are the ones that become demented, and 80% of the demented are the ones that stay demented. And we get our number of demented. Now, we put both of these rows into a matrix. Okay, now we've dealt with augmented matrices, so we're not talking much about that today. As we get into review next week, that's another thing we can talk more about. But I want you to make sure you've worked it out first. And that's all in the assignment for this weekend. Okay. I take my 0.9.2 and put it here. I take the 0.1 and 0.8 and put it here. Then I multiply it. How do I multiply it? I take the first row times the column, and that goes in my first row. There's a calculation for the first row times the column goes in the first row. First row times our column. Second row times the same column. Second row times the first column. I said second column. It's just times the column. We don't have a second column. So that's a mistake I made. Okay. Second row times the column. There it is. Okay. And there are numbers. So if we know how to multiply a row times a column, we get a result. Then, if we multiply the same matrix by our result, 554.50, we're going to get 585.450, which is exactly what we get if we do this. Now, what's the advantage of doing this as opposed to just doing it like this? Well, there's a big advantage. If we square this matrix, how would we square the matrix? How do you square something? Okay, well, people look at this and think, okay, you just distribute that 2 over everything in square 9, square 0.2, square 0.1, square 0.8. You don't do that any more than you would square x plus y by squaring x and squaring y. Squaring doesn't distribute over much of anything, okay? And it certainly doesn't distribute over adding binomial, sum of over binomials. It certainly doesn't distribute over matrix. You square something by multiplying it by itself. How do we multiply this matrix by itself? Well, how many rows does matrix have? How many rows are there in this matrix here? Show me with your fingers. Okay, well, you're still with me. Are seeing that there are 2 rows, 1, 2, okay? And there are how many columns in this matrix? 2, right? So give me the number of a row and the number of a column. Number of a row with one hand, number of a column with the other hand. 1 and 1. Okay, we can multiply the first row by the first column. Okay. Okay, give me another number for each. 2 and 1, or 1 and 2. Okay, we'll take that as 2 different answers because they are. Okay, so if we do 2 and 1, row 2 times row 1, here's row 2 times column 1, this row times this column. We can multiply this row times this column, can't we? Just match up the numbers, multiply them, and have the results. Okay, and we could do then row 1 times column 2, row 1 times column 2. Or we could do obviously row 2 times column 2, and that's it, right? Okay, so let's do row 1 times column 1, then row 1 times column 2, then row 2 times column 1, and row 2 times column 2. Okay, we do row 1 times column 1, and we get 0.9 times 0.9 plus 0.2 times 0.1, right? There it is, 0.9 times 0.9 plus 0.2 plus 0.1. Which row is this in this matrix? Row 1 or 2? Show me with your finger. Is this here in row 1 or row 2? It's in row 1. You know, right here's row 1, here's row 2 of this matrix. Okay, so we took row 1 times row 1, row 1 times column 1, and put it in row 1, column 1. Okay, because this is also in column 1, right? And then we do row 1 times column 2. Which row do you think that's going to go in, row 1 or 2? Row 1 times column 2. Going to go into row 1. We use row 1, so it's going to go into row 1. Okay. What column are we going to use? So it's row 1 times column 2. We're going to use row 1, column 2. Where's row 1, column 2? Here's row 1. Here's column 2 of the new matrix, and there it is. Row 1, column 2. 0.9 times 0.2 there, 0.2 times 0.8 there. And then we take row 2 times row 1, right there are the numbers from row 2 of the first matrix, column 1 of the second. And then row 2 times column 2, there are the numbers. Now you should be able to do those numbers in your head, just multiply decimals, okay? And all the numbers are 1 digit. All the numbers we multiply are 1 digit. 9 times 9 is 81, 0.9 times 0.81, 0.9 times 0.9 is 0.81, okay? And this gives us, well, this gives us 0.09 plus 0.08. What did I just do? When I add this, 0.2 times 0.1 is 0.02, add that to 0.8, 1, you get 0.83. Okay. Do this, you're going to get 0.34. Do this, you're going to get 0.17. Do this, you're going to get 0.66. Okay. So there it is. Now, one thing about this matrix, I'm not sure you're going to need to know it for the exam, but it's interesting. Let's go up to this matrix. What do you get if you add 0.9 to 0.1? Show me your fingers. You're going to get 1, right? What do you get if you add 0.2 to 0.8? You're going to get 1. Okay. What do you get if you add 0.83 to 0.17? It's going to be 1. 0.34 plus 0.66, it's going to be 1. The columns add up to 1. Okay. These are called, a matrix that does that is called stochastic. Its columns all add up to 1. Okay. If so, it works as what we call a transition matrix. We have a transition. We have a certain number of sane and demented people before the first exam. Now we have a different number after the exam. Okay. And then we can apply the same matrix to calculate the number after the second exam, right? Now, if all we want is the number after the second exam, we can just take our original 500 and 500 and multiply it by this. Okay. If we have a situation that involves a dozen transformations, well, calculating the 12th power of a matrix gets a little bit involved. But any decent software that's free and easily available will do the 12th power of any matrix, any reasonable matrix. Okay. Yeah, mess with the pivots until arithmetic breaks down, and maybe not, but you don't need to know that. Okay. There are exceptions for what I say, but any matrix that you're going to run into, any transition matrix, it doesn't have really tiny numbers in it. You can calculate the 1000th power if you want. Okay. Now there's much more that can be said. I'm just going to say that matrices are kind of a basis for linear algebra, which is, of course, you probably never take, got to have a full year of rigorous calculus, not just applied calculus, to take a linear algebra course. Okay. And it's pretty challenging. Maybe not as challenging as a year of calculus, but it's pretty challenging. It's neat stuff. It's very powerful because most of the mathematics that gets done is either calculus or linear algebra in the real world. Okay. Kind of governs everything. So I encourage you to learn more about it. But with your curriculum, most of you are not going to get to a linear algebra course. And you're going to have a rigorous calculus course first. Typically, to get to a calculus course will be the applied calculus. That's going to be good. Okay. It's a good course. So this is the beginning of something really important that you want to know a little bit about. And there are also applications, especially transition matrices, applications to things you will want to understand. Okay. You can do a model of the stock market. It doesn't work, but you can do a model. Every day you have a transition, it either goes up or down. What's the probability it goes up or down? Okay. And then you multiply that by what happened the day before. Okay. Well, I'm not going to go into details of that. It goes beyond what we need to do in this course. But you do have models of that nature, and if they get modified a lot, especially maybe by artificial intelligence, all kinds of stuff comes out. And artificial intelligence is taking off exponentially. It's got great power for benefit, great power for harm. To wipe out the species or make the species secretive. Depending how it's today. Well, anyhow. Okay. Let's just do an example of a matrix multiplication. Right there's the rule. Multiply rows by columns and put them in the corresponding row and column. What do you get if you multiply those two matrices? Doesn't have anything to do with 1, 2, 3, 4, 5, 6. The answer won't be anything you can get from the sequence 1, 2, 3, 4, 5, 6. That's as far as I go through things for different single digits. That's enough to illustrate matrix multiplication. You're just multiplying rows by columns. You multiply every row by every column and put it in the row and column corresponds. This is going to look a lot like this, just the numbers are going to be different. Let's see if you can figure out what this is going to look like. Okay, most people are doing just fine here. Let's go ahead and do. Incidentally, note that this is not a transition matrix, it's not stochastic. Columns don't add up to 1. Okay, I just use sequential numbers because for an illustration. What's this? Row times column. 1 times 5 plus 2 times 6. And 3 times 5 and 4 times 6. That's 5, that's 12, so that's 17, that's 15, that's 24, so that's 39. Anybody agree? Anybody get those numbers? So did I screw up? 1 times 5 is 5, 2 times 6 is 12, 5 and 12 is 17. We've got to add this to this, right? Did you get it? Okay, you got a question, hang on. Okay, there's a little confusion. Some people might have thought it's 1 times 5 and then 2 times 5. No, it's row times column. The whole row times the whole column. You got to use every number in the row and every number in the column. You got to match them up, multiply them, and then add the results. Okay. Now you're going to have open math things, and it'll clarify any of that. Even if you only get half the process here, it's not difficult. But you want to be careful. Okay. And then 3, 4, 5, 6 is 3 times 5 plus 4 times 6. And that, I think, is what we end up with. That's 15, that's 24, and I'm pretty sure 15 and 24 add up to 39. Okay. Or this one. It's first row, first column. 1 times 7 plus 2 times 8 plus 3 times 9. First row times the only column. Second row times the only column. It's 4 times 7 plus 5 times 8 plus 6 times 9. And that equals what? 7 and 16 is 23 and 27 is 50. 4 times 7 is 28, and 40 is 68, and 54 is 114. I did that quick, so no question mark on that, check it. Fair enough? Okay, now to a couple of equations. Just to review, something you should know, but it's been a little while maybe since you did it. This equation can only be true if this is 0, or this is 0, or this is 0. So this breaks into three equations: 3x plus 5 equals 0, or 2x minus 7 equals 0, or x squared plus x plus 7 equals 0. I didn't leave myself enough room to write that. It might be hard to read from back there. Might even be hard to read in the screen, although I think it'll come out. So you solve this equation. Subtract 5 from both sides and divide by 3, you get this. That'd be x equals 7/2 here. And there's no real solution to this. As you can tell, when you plug into the quadratic formula, you're going to end up with a square root of negative 48 in there. Okay. Now, if there was a real solution, you can find it using the quadratic formula. If I put a 10 in front of this x, then there still won't be a solution. Okay. If I put a 12 in front of the x, yeah, there will be a solution. 11 in front of the x, I think will be a solution. Okay. Or if I put a negative sign in front of that 7, there will be a solution. So just depends on how that square root works out in the quadratic formula. Now, sometimes you can factor this to get the solution. Okay. That'd be an appropriate thing to do. What about this one? It's an absolute value equation. You're going to get x squared minus 5x plus 6 equals 8, or x squared minus 5x plus 6 equals negative 8. Why? Because the absolute value of 8 is 8, and the absolute value of negative 8 is negative 8. So if this thing in here comes out negative 8, you got a solution. And that's what you have to do. Okay. Turns out you're not going to get a solution from that. You will get a solution from this. So we can complete this: x squared minus 5x minus 2 equals 0. Now it's in standard form of a quadratic, and we can apply the quadratic formula. X equals 5 plus or minus square root of 25 plus 8 over 2 times 1, which is 5/2 plus or minus square root of 33 over 2. So quadratic formula, if I've done it correctly, make sure to check my work. Okay, here we get x squared minus 5x plus 14 equals 0. I can see right away that the square root's going to come out negative. Let's just write it out. X equals 5 plus or minus the square root of 25 minus 56 over 2 times 1 equals 5 plus or minus the square root of negative 33, 31 over 2, which is, of course, 5/2 plus or minus plus 31 over 2 times 5. But it's not real. Okay. So should be able to do all that. Expect an assignment over the weekend, tries to tie things together and get the section done on matrices. Okay. Then hopefully everybody's in good shape to do a really good review next week and do well on the exam.